Hello and welcome to the Hello Allegro task. This is the third task this week where we have to create a red triangle. And unlike the previous two tasks, Hello Canvas and Hello WebGL, this task is done in C++. And we are going to use the Allegro game programming library. Allegro is software library for video games, but it can also be used to just do computer graphics. It's a really easy C++ library to get into computer graphics. And when we download this Hello Allegro zip archive, we can see what's in the code. So I already downloaded the hello allegro.zip, and I've also unpacked it. And that's the contents of the directory. And with C++, we want to open it with the code, the Visual Studio Code, and that's the contents of the directory here. So we have a bunch of CMake files here. First, we have rules for compilation. So this file, you don't have to change it, but this file has all the dependencies. So we can see that we want to use Allegro, so we use Allegro primitives, and all the other Allegro pieces. Then we have CMake presets. This comes, this will be used when we press this button. And we will see later that we have to get this homework task preset. And we also have the VC package files. So in this course, we use VC package to automatically download and install dependencies. But the caveat with this way of creating the dependencies is that it will take some time to download and compile and install the dependencies. So the first compile of the code might be slow. But let's get into the source code as well. So C++ is a bit more involved than JavaScript. It's much more low level. You have to manage your own memory. The compilation process is much more different than the interpretation process of JavaScript. And for that reason, there is much more verbose. And yeah, first we see that we are including some things. So we use IOStream. So for this, if we wanted to print stuff out onto the terminal, then we use mathematics. And if you have done already the previous two tasks, then you know why we need the mathematics here. And then we also include the Allegro things. So we use Allegro and primitives and color as well. Then there are some Allegro things here, for example, display, event queue, the event objects. And then we have forward declarations. So in C++, it's very important that all the functions that you use in your code have already been declared. They don't have to be defined, but they have to be declared. So the function declaration is just like definition, but instead of having curly brackets here, we just end the line with the semicolon. That means that the compiler now knows that this symbol exists, so that code is valid. And the definition is linked into this place here during a linking phase, which is part of a compilation process, which is done later than parsing. And we see that we have 5 different functions here, or actually 6. Main is not declared. We see that we have an initialization function. We have the deinitialization function. We have event loop. We have a draw and draw triangle. So we'll go through all of them after the main function. And the main function, that's the entry point of the program. So if you have a function that is called main, that's the first thing that is called. And we see that in the main, we first call init, then event loop, and then the init. So let's look into the init function. Init function just initializes the Allegro. We also see that we create a display, which is 640 by 480 pixels. We create an event queue. Event queue is for rendering and also all the other events. For example, key presses are events, or moving a mouse or clicking a mouse button. Then we see that we have to register an event source. We see that the display is the event source. So if we have a display focused, then we can get events. We also install a keyboard. Keyboard will also be an event source, so we can press buttons. And then we also initialize the primitives add-on. So let's look into the init as well. So we just destroy all the resources that we created in the init function. And this is important because they are not destroyed by default. C++ does not have automatic memory cleaning with the garbage collector or anything like that. We have to free the memory ourselves. So we see that we destroyed the event queue and we destroyed the display. And then we can just finish the program here by returning 0, which is a non-error. Now, the more interesting part of this source code is the event loop and the throw function. So the event loop, we see that this is called after the init and before the init. And the event loop, as the name suggests, is a loop. So we see that it's a while 1, which is equal to while true. And we do two things here. We first see if there are any events. And we'll check for two specific events. We check for display close. So if we close the display, or if we press the key up button. If one of these events have occurred, then we call a break and we exit the loop. So that's the way to close the program. So if we exit the loop, we call the init and then we return 0. So that ends the program. The second thing that we do in the event loop is the throw function, which will have our logic in it. And that's where the computer graphics starts happening. And we can actually see what's in the throw function itself. See that the first thing we do is we clear the color. So we want the screen to be black. So 0, 0, 0 is black. It's no color. Then we call a draw triangle, which you have to implement yourselves. And then finally we flip a display. So why do we call those two things? So the low-level rendering pipeline has two buffers. So we have double buffering mode here. And this is important because when we are displaying an image, we don't want to change that image. But we want to do the computer graphics calculations while we are displaying the image as well. So we need two buffers. One is for displaying and one is for doing computer graphics calculations and putting the right pixels into the right places. And when we do computer graphics related things, for example, clear the color or drawing a triangle, then that will go into the buffer where we can edit the things. For example, we have this dirty buffer and we reset it to black, then we draw a triangle on it, and then we flip the display where we switch those two buffers. So now the buffer where we edited the things becomes the screen, so we can actually see what has changed. And the buffer that was displayed on the screen now becomes the editing buffer. And we can change those things. We can change the editing buffer with the functions again. For example, we want to clear the color to black or any other color. And so that's the gist of the low-level rendering pipeline. And so in the draw function, we always switch from one buffer to another, and then from the other to the one again. But your homework task in this source code is to implement the draw triangle function. And to do that, we have to find the correct vertex coordinates and then draw the triangle. And to draw a triangle, we need to use this function called all draw filled triangle. So if we go to the documentation, you can see what it looks like. So it takes in the x1, y1, x2, y2, x3, y3, and then also color. So we can see what are the parameters, definitions of the parameters. See the 3 points of the triangle. So the first point is defined by x1 and y1. And we also have color. So we can see from here that we want the color to be red. And we can use the allmap RGB for the color. But that you have to do yourselves, and make sure that the triangle is centered around x and y. So we have to choose two arguments for the triangle, and we want the center of the triangle to be at 320 and 240. And you can, and that will now create two triangles. And you can also even do another tests when you actually add a third argument here and create two different colored and two different sized triangles on top of each other. And if they are overlapping perfectly, then they are then the triangle center is in the correct position.